Good morning, everyone. Today, I'm here to talk about on the topic Quantum Age Begins, Its Potentials and Challenges. Today, we are entering a new era called the Quantum Age. Just like how the Industrial Revolution revolutionized the society and the digital age revolutionized how we are able to compute things and how we are able to calculate things. Just like this quantum age promises to enhance our communication, computing, and sensing. Today, let us explore some of its potentials and challenges. Firstly, let us talk about its first potential, that is in quantum computers. Some of its potentials are faster computation for complex systems, simulation of complex systems, optimization and machine learning, and its challenges are quantum noise and error correction, scalability and control, quantum algorithm, and development. Now, for us to understand better how quantum computers work, let me take an example. Say, I'm trying to clean my house and my friends are coming. I have to finish it before my friends come. So if I were to do it normally, then I'd go to one room and then clean it and then go to the next room. But this would take too long and my friends would arrive by then. Now, imagine, I could shrink myself down to the size of an atom, then there's a rule called superposition in which I can exist in multiple states. And now, because of this, one version of me could be cleaning one room, while one version of me could be cleaning another room. Due to this, we are able to finish in time. Just like this, quantum computers use qubits, which are tiny atomic level, and they can exist in multiple states, just like how I was existing. And due to this, they're able to do multiple kinds of calculation at once, hence increasing its speed. Now, there are some challenges, like I said, which one of them could be quantum noise. For superposition to exist, it needs to be isolated from the environment. So, if it interacts with anything in the environment, then it will disappear. And due to this, we are unable to create a system in which we are able to keep it in its superposition state for too long. And that is why it is very difficult for us to keep it in superposition state. Secondly, let us talk about quantum communication. Some of its potentials are secure communication through quantum encryption, unhackable data transmission, quantum key distribution challenges, scalability and infrastructure development, noise and error correction in quantum channels, practical implementations, and cost effectiveness. Now, what is quantum communication is what we have to first understand. Let's say I'm trying to send a message to one of my friends. Now, if it was normal, then I would just send it. But during this time, one person can just intercept the message and then look at what I'm trying to send. And this would be invasion of privacy. Now, if quantum communication comes into play, then we're sending a tiny little information dot. When this information dot travels, then if anyone tries to peek into it, then it will change due to quantum entanglement, which we'll learn about later on. Now, when it changes, then we'll be able to know that someone is trying to intercept the message or about what we are trying to send to some of our friends. Now, if we know about it, then we can just stop it and our information will be safe. But there's another challenge that comes with it, and that is scalability. Since it is so small, then if we try to give it over like long distance, like I'm in India and my friend is in New York, and if I try to send it, then it can get lost. So because of that, it is still very problematic, and we are unable to develop anything that can help in channeling it. Now, nextly, I'd like to talk about quantum sensors. First, its potentials are high precision measurement and sensing, navigation and positioning, scientific research and discovery. Some of its challenges are sensitivity to environment noise, stability and calibration, practical applications and integration. Now, when we talk about quantum sensors, it is about using the highly sensitive nature of qubits in a form of technology. Now, we know that qubits, even if we just touch it, then it will disappear. Now, what if we use that to create quantum sensors? Let's say I'm trying to keep my room temperature at around 20 degrees Celsius. And if it needs to stay that way, then we use an AC. But If something like the lights go out, then the room gets hotter, and this can be detected by quantum sensors, since they can detect any kind of measurement at a very precise scale. Now, high precision measurement and sensing, when I say that, it means that it is able to detect all kinds of information. And it is able to detect like how magnetic fields change, or how if there is anything, if the gravity has gone up a bit or gone down. But there are some challenges. It is so sensitive that if it interacts with anything, then it will disappear, like I said. And for practical applications, we are still unable to develop it since it is very difficult. Now, to conclude it, I would like to say that quantum technology holds immense potential for transforming various fields like medicine or defense, communication. While challenges exist, ongoing research and development are paving the way for how we can utilize the quantum potentials, and due to this, we are able to harness all kinds of potential while also facing the challenges we must face. The quantum age is upon us, and it is essential for us to prepare for it, for the opportunities and challenges it brings. Thank you.